we're all okay with that. Okay. So thanks everybody for coming again. This is week 2. I think we had a fun last week, Saturday and Sunday. Was very great, and thanks to Vishal and for the work for the presentation and just walking us through a lot of the intro to Python. I think today is going to be more. We're going to go into even more important concept like functions and maybe pandas and NumPy. So I think it's going to be exciting. But before we do that, I'll just have to do like a Menti survey so I can just gauge, where we are in terms of our experience with the course so that we can continue to improve, in the coming class. So let me know when you see my screen. If you can go to this www.menti.com and put the code that you see on the screen, 2424559. Be as objective as possible because we're going to continue to use this to refine how we deliver the course. Any more? We have maybe a few more people. Wow, this is great. So it looks like, we're meeting and exceeding expectation. Of course, this is just week 1. Week 2 is going to be even more fun. So, stay tuned. And with that, I just wanted to do this to be able to gauge how we are delivering the material. This is also a good learning for even the instructors to continue to refine, the way we deliver the class. So with that, Vishal, I would stop sharing. Thanks a lot for the survey. I'll stop sharing and I'll let you pick up from there.
Thanks, Michael, for, it's important for us, like you said, to understand what we need to improve, and, feel free to, if there is any specific comments and anything. So yeah, just we are very open to it.
Yeah, and use the Slack channel. We have a Slack. I want this to be a community. People have different experience level. Some of us are, beginners to this. So feel free to go on that channel, ask questions, and we want the people that maybe have some intermediate skill to continue to respond and continue to support. I would encourage us to use that as a means of communication. I know people have been exchanging email. I just want to put a disclaimer that, the means of communication we provide is the Slack, and if you're providing emails to other individual, it's not, it's at your own, time and risk. So, but make sure you maintain your communication within the Slack community. All right, thank you all. So Vishal, I'll let you take it from there.
Sure. Yeah. No, thanks, Michael. So can you guys see my screen and hear me fine?
Yes.
Okay. Perfect. Yeah. All right. So welcome back, everybody. I had fun last week. Going through the different material, and as I said, every time I do this, it's always good to learn new things. So yeah. So I hope you guys, have gotten a chance to play around with Python, and hopefully it's been fun for you guys. Um, and you are liking it. Some of you I know have done different other programming languages, so maybe you guys can give your comments on the chat box regarding some of the things that you find better as compared to other programming languages in Python, or some of the things that you do not like. But I just wanted to do a quick recap of what we learned last week. Essentially, we did start off right from the basics, right? So we started off with the different data types, and we looked at some simple operations. We looked at packages that we could that we could use from the different packages that's out there in the public domain. And also we looked at three different Pythonics like objects. These were lists, dictionaries, and tuples, right? So those were three different things with three different specific usages, and we saw different examples of that. We played around a lot with combining strings, combining print statements with a lot of variables and stuff like that. So yeah, so hopefully you guys remember that, and we'll build upon that. So that was like the big foundation that we would you know try to leverage as we move forward. And yeah, right at the start of this, and tomorrow when we have our discussion sessions, we'll have a guest speaker who I am very excited to hear, and we'll see more on this. But I just wanted to start off with something which is which is more catered towards going forward using Python, and how Python is being used in the community. So I hope you guys have heard about this thing called GitHub. So it's essentially uh, if you are writing your codes, so GitHub is essentially a version controlling like platform. So essentially what it does is it's gives you a platform where you can share your codes with different people, and also keep a tag of what improvements you're doing as you go around making different softwares and packages and things like that. So um, and you would hear this term where you will find that somebody has done something cool, and we'll show an example here, like a tic-tac-toe game that they built using Python, and you would hear this term called git cloning. So what essentially it does is essentially you take that package, download it, and then start using it. So a quick a quick note here. You will see that I have this line here. So essentially any line in Google Colab which starts with an exclamation mark essentially turns the Google Colab notebook into a terminal prompt. So all the commands that you use for terminal, I know there are some Linux users in the crowd, so you can use this exclamation mark to actually do a lot of the terminal commands in the Google Colab cells. Let's look at this particular GitHub repository. So essentially, what does this GitHub repository have, and how does it look like? So this is by someone with this particular name. So it's actually, I didn't know that, but this person is I'm not endorsing anybody here, so just a statutory. So I just was searching for something very basic and cool to show to you guys. So this guy is a PhD candidate at Georgia Tech, and he wrote this small code where he's using Python to make a user interface with a tic-tac-toe game. And the way that you yeah, sorry, thanks for reminding me. So the way that you use this is essentially you clone this particular GitHub repository, and then you go into this clone repository directory, and then use your Python code to access the code that they have. And another way to get the code is to use this code downloading scheme, where you can either download it as a zip file, or if you have GitHub installed in your computer, you can use the GitHub desktop and stuff like that. So very high level, I just wanted you guys to at least be aware that there is something called GitHub and GitHub repositories that you could use for using some of the codes that's out there. And I actually did this for you guys before the start of the course. So I have downloaded the tic-tac-toe master. That's essentially this particular folder, and inside this there are different things. So what does it have essentially? So it has this main.py, that's a Python script, and we can open that using any editor. And you would see here, there's something more fancy than what we did. So you can relate to some of the commands, right? Like we had this from to import different packages. Remember, there was a lot of discussions last Sunday about the math package, the math.py, and what you need to import and stuff like that. So you can relate to some of these are like assigning the variables and whatnot. But then they start doing something fancy, and this is where it's all related to the object oriented programming. And we will see what this def and all of these things are. So essentially these are what we call functions, right? So when you the take home message from this is that if you want to write something cool, you need to go into a object oriented programming kind of a framework and define functions and classes and stuff like that. And we will go through defining functions in this lecture today. But if you have a function like this, or if you have downloaded the GitHub repository, then you can actually use another thing which I kind of alluded to last time. So I said that we have different IDEs, integrated development environments, and one of them is Anaconda, right? So I have Anaconda installed in my system, so I could use that as a terminal here. So I'm sorry, this might be a little bit small for you guys, but I don't know how to make this bigger actually. But yeah, so it's I hope you guys can see at least a little bit of it. All right, so I'll paste this GitHub link, and you would again like last week, we will send out the um class notebooks at the end of the course today. So essentially, you go into this particular directory where we have downloaded this master, right? And then you use this command. So Python is the command that you use to invoke the Python codes, and then you say Python main.py. And what it does is it's essentially executing the main.py code that we just saw. And as a result of this, you can actually make something pretty neat like this, a GUI, where you can play the TikTok game. So you can do what we do with the TikTok, right? So you can start playing, and then yeah, I know the trick here. I win. So yeah, so essentially again, I'm trying to show you that you can use Python simple codes to actually do something really fancy. And tomorrow also we will see this from our guest speaker, hopefully, on how to use this. But once we once we are writing all these fancy codes, we need to make sure that we have to write functions to make cool things using Python. So having given that background to you, now we'll go into writing our first functions, right? So we'll see how we can write functions, how we can execute them, how we can use them. And one big utilization of function is that you should write functions for things that you tend to do repeatedly, and it just makes the coding very, very organized and very nice. So I hope you guys remember how to open a Google Colab notebook. You can use the notebook that you had before, or you can open up a new one. So I have a new one in here, and I'll start writing our codes today in this one. So Let's write our first function, right? And let's do a simple arithmetic operation. So last time we saw that we could use the asterisk to, to do a product of two numbers or more. But let's try to do a function that calculates the weighted average, weighted the product of two numbers, right? So for this particular function, what we will need is input would be your two numbers and the weight, right? So it's essentially, a weighted product of two numbers. Sorry, product of two numbers, right? So the first thing that we need to keep in mind when we're writing functions is the formatting. So how do we write functions? And this is what was there in that main.py function. So you define a function by invoking this command def. That's how you say that the program that you're writing a function. Then what you do is you put a function name. So in this case, let's say we say it's a weighted product. And you can the idea is to have a function name that is intuitive enough and you don't forget about it, right? So it can have any name that you want. You can even make a function with xyz as the name, but normally it's a good practice to actually have the function some good name that you can relate to later when you use the function, right? So this is the function name, and then you open parenthesis, and inside that what you do is you put in the inputs, right? So in this case, let's say my first input is the first number, which I denote by x, comma, the second number y, and the weight, right? So x and y are the two numbers, and then there is the weight. And then as we had in the for or the if loop, and it's quite standard in Python, so I hope you guys remember the for and if loops. So we end the first line with a colon, and then if you press enter, it should come up to the next line with some white space. So remember, white space is important in the for loops, in the if loops. It's also very important in the function, right? So this is the first step, the first line of defining a function. The next thing that is again a very good practice, although it's not a requirement of a function, but I strongly encourage you guys to bring this into your culture and do this for each and every program that you write or function that you write, to have some description of that function, right? So remember, I'm hoping that you guys will become expert programmers and would write functions day in and day out, and you'll keep forgetting stuff unless you have not as poor a memory as I do. You would find it hard to remember, and also remember that some of these functions you might actually give to others for their use, right? Hopefully one day I'll see one of you guys from class with a very nice package that you have contributed to the Python community, and you have functions in there. So you need to make it informative. So in order to add comments for a function, we use three single quotes. Okay. So this is just like, there's no hard and fast rule. You could have done it with the hash symbols as we have in here, but this is how normally people would write, and why we use three is because you can include anything in between these three open comments. So when you start a comment, you start it with three of these single quotes, and then you end it with again three. So anything in between this is a comment. Okay. So I can say that, just to make this informative, I can say this is a function that takes in two numbers and calculates a weighted product. Right? So that's I hope intuitive enough, and you can come up with your own statements like this, which would be useful and pretty generic for others to understand. The other thing that I like to do is, I like to describe what the inputs are and what is the output that you would get. So I'd say input is x comma y, which are the two numbers, And then my other input is the weight, right? So that's the weight used in the weighted product, right? So I hope that's intuitive enough. And then, another good practice that I was saying was to also, uh, describe what you would get. So the output will be a weighted product. And if you do, develop codes as part of your work, and there are copyright issues and stuff like that, there is normally a whole disclaimer after a function that you own this function. And again, I like to also tag this with dates when I'm writing this, and also if I improve this function later, I would add comments in there. So I'll just say that written by me on 14th November 2020. So that's just for my own information, and also for others to know who has written this function. So hopefully this is intuitive enough. And now we go into outside this comment box and start writing the code for this. So this is a simple function, right? So we can say the output, which is prod, is actually x multiplied by y multiplied by the weight. So now you could have told me like, hey, I could have done this outside as well. Of course you could have, but imagine a situation where you're using a weighted product over and over again. So instead of typing x multiplied by y multiplied by weight, you could just put in the inputs inside this function and then use it directly. So that's the power of it. So this is the expression. You can have as much of expressions as you want inside a function, but for this case, this is enough for what we are trying to achieve. And a function ends with a return statement. So essentially, a return statement actually gives you back the control back to the next line, right? So when you're executing a function, so in this case, you can say that I want to return prod, which is the output, right? So, all right, hopefully this is clear enough for you guys. So now I'll execute. So to make this function available for this particular notebook, we'll have to execute it. Remember, we can execute using the run cell or the control and enter option. So I'll run cell, and this is where I'm getting the resources. I got the resource from Google. It was pretty quick. And yeah, so now I have this weighted product as my function. So all right, let's try to use it now. Yeah. So now to call our function, we will just use the name of the function. So weighted product. So you see, we have a nice autocomplete in Google Colab, and this is where the beauty of the comment section comes in. So you see when I clicked on the info for this, it actually reads the first part of this function, which is the comments, right? So if somebody else, or even you, if you're using your own function and have forgotten what it does exactly, then you can click on this info and it'll tell you, okay, I need like 3 inputs. This is how I would write the function, and then these inputs are these particular in this particular order and whatnot. So all right, so for us, we'll just say weighted function, weighted product, right? And then we can you know we can do something on defining the variables, right? Remember, so we can say that number 1 is equal to 100, number 2 is equal to 200, and the weight underscore uh, test. I'm gonna define my weight as weight underscore test. That's the name of the variable, and I will multiply the product by 1e minus 4. So this is almost like dividing it by 10 raised to the power minus 4. Uh, so yeah, so once I have that, I'll go into weighted product and I'll say my first input is number 1, right? My second input is number 2, and my third input is weight underscore test. And now we'll try to execute and see what this gives us. So, all right, so what it has done, what we intended it to do. So it has essentially multiplied these two and divided it by 1e minus, or multiplied it by 1e minus 4. So that gives us 2.0 as the uh, value.
Sir, a small doubt.
Mhm.
Sir, we use three apostrophes for formatted strings, but in this function, how can the Python program knows whether it is a comment or a formatted string?
So this is how this is by design of how you define a function, right? So if you have a function with this, like this style of writing, it automatically detects it. So I think even if you have a formatted string as your first line, right? So it will take that as a comment, and that's by design of how the programming language works.
Sir, what if we want to print some formatted strings within the function?
So let's try to do that, right? So can you tell me what you want to do? So we'll use the print statement, right?
Yes, sir.
And what do you want to print?
Just something like this is Python program to find the product
This is Python program to
to
find the
calculate
calculate.
a weighted product.
That's it, right? Okay, so if we want to print this, so we'll put that in here, and now let's calculate the weighted product. So it does what it's intended to do, right? So you can use print statements inside the function. So it will print your whatever you want to print.
Sir,
So this is
actually, can't we print the formatted strings without using that print statement? Rather, we can use that print statement to print the function. So, as we should type, as you have said that that is a comment, why that should not act as a string if we print the function?
Yeah, so I think this is a little bit specific. Maybe we can discuss it tomorrow during our discussion session. So if you, I'd encourage you to, work out an example, what you want to do, and try and attempt to write a code, and then we can bring it in front of the class, and we can see, like, what we can do to achieve what we are setting out as. But I think in the interest of time, I'll just emphasize, on the fact that to this is how you would define a function, right? So using the diff and this particular statement, and the first part of it using this particular format would always be used as a comment and not as a string. So
Is
that
that only the first part, or can we use that format anywhere in the function?
you can use it anywhere in the function. So it's just how you define a comment, right? So you can say this is my new comment, and it'll ignore that part. So, and I think when you would go into here, so it will not show that second part of your comment in there. That's just for you inside the function to define a comment. So this is essentially how you define comments. But the nice part of the Python functions is that the first part of it, if you define it as a comment, then it'll come as an information for that particular function.
Sir, how the 2 is printed without using that print statement?
So because so this actually returns the product as an output. So you could have, if you do not give it a name of the variable. So that's a good point. So let's say if I would have said that this is product underscore answer, right? That's the name of my variable. Then it would have not printed it. It would have just stored this return into this product underscore answer, and we can try this. So then it doesn't print it, right? But if you do not have this defined as a variable, right? So, and if it is at the last line of this particular cell, then it actually gives you the number in the output as well. but good point. So you should normally try and write out your the whatever you're getting out of your function as a variable, right? So that ways you can access it. You can now say that uh, print product underscore answer, right? So that will actually print out 2.0 for you. All right. So if there are no burning questions, I'd like to move forward. We have quite a bit to cover today. So um, yeah, but feel free to put them in the chat. If we can't get through them, we will try to address them tomorrow. So now I'll go into another aspect of
Vishal, maybe
yes.
in the interest of some of the beginners, I would like to see if there's any questions or any concern or any clarification you need on this first part, because we're going to build a lot on the function and definitions and creation of functions. So are we all good with this example? Okay, so I see a lot of yes, so that's good. I just want to make sure we don't leave
Yes.
anybody behind
No,
just because
that's
of
a
the
good one.
diverse class that we have. So
Yeah, no, thank you, Michael. I I rely on you to keep me on check, or else I'll go on a tangent and just start blabbering. So no,
okay,
thanks,
so
thanks.
someone said they tried it and didn't get the same answer.
Okay, so can you come off mute and describe what you're getting and what you tried?
Yeah, or copy your code and paste it on the chat.
Right, yeah.
Yeah, so
So I'm sure there is, I mean, this is a simple multiplication, right? So x multiplied by y multiplied by weight.
so he posted this code here. Sure.
Okay. So let's try and bring that into the notebook.
Yeah, sorry, I'm not trying to drag back, but I just
No,
want
no,
people
no.
to get the beginning.
Yeah, no, definitely. That's a good one. So, all right, so I'll reformat it because when I paste it, I don't think it's formatted correctly. So I will say, okay, weighted product. Let's
Oh,
do
okay,
this.
somebody already mentioned the answer. I think it's just a typo. He has
Oh,
num1 twice here.
yeah. Thank you. Yeah,
Thank you for that response.
yeah.
Thank you.
Yeah.
All right. Any other questions?
All right. I think we can carry on.
All right, perfect. Okay, so you've seen, like, we could define our function in here, but let's say we want to assign some default values to these variables that goes inside this function, right? So let's say I know all the time that I'm going to use most of the time I'm going to use the weight of 1e minus 4, and I want to use that as default value, right? So in this part we'll see how we can assign a default value to some or all of the variables in a function, right? So I'll copy paste what I had before. Yeah, so I can you keep working on this particular function. So this is my weighted product, x comma y comma weight. So now let's assign a default value to the weight and say that the weight, if nobody assigns it specifically while calling the function, we will take the weight as 1e minus 4. Okay, so the way to do it is, you just say weight equal to 1e minus 4. That's the only change that you make to this whole function, right? I'll get rid of this print statement and the comment line later, right? So and I can add to my input like weight using the weighted function default equal to 1e minus 4, right? And on this you can put another added comment. This is required input. So you'd have to have two inputs for your function to work, but the third input is optional, and if you do not specify anything, then it's going to take the default value of 1e minus 4. All right, so now I execute this cell so that my function is updated, right? So now I'll do the same. So I'll say weighted product, and then I'll say number 1, think. Yeah. And I should get the same result as before. So now you see, I do not have the third input. So that by itself is taken as a default value. So the other part which I wanted to mention is that you can actually write these functions and save it in a text file, right? So you can actually copy paste this function. So I have a question. So let me see what is in here. So the function is chosen based on inputs. Can you clarify that question? You can come off mute. I think this is something that we can take for the whole class. So yeah, so there are now two. I see what you are mentioning. So there are so what happens is like based on the order in which you execute the cell, it is actually the the memory stores that. So essentially, you do not have two weighted product, although they have the same name. And a good point actually. So because I executed this cell as my last cell, and I didn't override this with the first cell that I had, so now my weighted function is actually this guy. So now if I accidentally, the best practice here would be to just completely get rid of this function, right? So but if so it just depends on the order in which that you are executing the cell. So if I would have, although I had the weighted function with the default value specified executed last, now instead of doing that, if I execute this guy, so now my weighted function is actually this one. So, and it should throw me an error in here. So it says that weighted product missing one required positional argument weight. Sure. All right. So I'll again execute this, and that means we have the output that we require. All right. So I was telling you guys that it is actually possible to copy paste all of these functions and put it in a text file and store it under a name. So it's again another basic best practice used in Python community, and I'm trying to as we go through uh, the class, I'm also trying to give you guys some of the best practices that we have. Um, so yeah, so one of the standard best practice is to write all of these functions and the store it under the name of utils.py. Right? So you can keep on pasting your functions inside utils.py, and then if you remember, so this is almost like a package that you're creating for yourself. So you can once you have it and saved it and you can access it, you can use statements like import utils that will actually import all the functions inside utils. Or if you have multiple functions from utils, you can say from utils import, let's say you had put um, the weighted product function in there, so you could have done that. So all this can be done. So just an FYI again for you guys. I saw a question about what can be if you want to complex return statement, could you also use something like return this? Okay, so let me actually bring that return statement in here for everybody. So okay, so yeah, you could actually do that, but normally a function is I mean, I don't know, like if there were other Python programmers here, I would have taken their opinion as well. But I would normally, not like to have these kind of complicated returns. Could actually break it down a little bit further, right? You could, instead of returning it like this, you could have said like, print this particular statement, and you could actually return none. So if you leave a function without a return, so if you just end the function but just saying return, it gives you back the control without returning any output, right? So if I were to do this, I think this is a question from Philip, right? So if I were to do this, I would write this as a print statement before the return, and then just use return without any output, right? So that's how I would do it. Yeah, but good question. All right, any other questions on functions? Yeah, efficiency and having the best practices in writing codes is the key. So we are going, I mean, I don't know if you guys realize that we have really, we started from basic, but with this, writing functions, we have actually, given a lot of, power to you as a programmer, right? So this is essentially how all the packages are written. So all the packages that you see and you use, and we will do a couple of packages today, like NumPy and Pandas. They're all written using this kind of a formatting. So method overloading, I am not sure if I understand this. I think this is more on the object oriented programming part, right, David? Uh, so yeah, maybe that's kind of an advanced question for me as well. So maybe you could search Google for that answer. Yeah, sorry, I'm not very familiar with method overloading, and we can discuss it tomorrow if you want, and we can go over this together. Yeah. All right. So if there are no further questions, I would like to go into something which is very interesting and that I use almost all the time. Um, so I'll go and I will take a little, step ahead now. We'll try to start scientific computing. Um, so that's where we are introducing the NumPy package. So NumPy package. So NumPy package is essentially a scientific package. It's essentially inspired by MATLAB and other scientific programming languages. It has a C++ based, library behind it, and it has time and again proved to be very, very powerful and if not one of the most used package right now for scientific computing. It has really shown its power time and again. So it's a package for scientific computing, and this is the website for it, numpy.org. That's the name of the website. You can go and read what are the different functions, and you can see um, it has really, really, gone a lot of distance to do something pretty amazing. So you can see there's the new realm in the physics domain about the black hole, the gravitational waves, and all of that. There were some use of matplotlib and NumPy that actually was used for all of this. It's pretty powerful, and we will see how we can use it today. So how do we access NumPy? So again, this is where Google Colab actually is pretty handy. So if you didn't have Google Colab, if you're using your local environment, local machine, then you would have to use install command. So normally it's the pip installer, pip install NumPy, and that would actually install NumPy for you. And you can find all the details in the NumPy website, how to install and whatnot. um, but in Conda, or no, not in Conda, sorry, in Google Colab, you actually have it installed, so we don't have to install anything in here. So we can actually use import NumPy, and this is where we'll do something more. So we could have said just import NumPy, but because we use NumPy so often, and because there are so many functions inside NumPy, we actually, it's a very standard thing in Python to do, to import NumPy as a short form, which we say NP. right? So that's how we would import NumPy. And um, remember, we could call a function inside a package by using the dot. So instead of using NumPy dot and the name of the package, we can now use np dot, and that would actually tell you, or do give you the functions and the usages. So yes, so there's a question that came in. Can we install libraries in Colab that are not pre-installed in the Colab environment? Yes, you can. So in the start of today's class, we introduced a thing just in passing, the exclamation mark, right? So you could use exclamation and then say pip install, and it just does what exactly in the similar way as it would do in your terminal, right? It would say it would execute the installation. So but remember, it's in a virtual machine, right? So it's not permanently installed. So some of these packages, if they take time to install, and if it's not in Google Colab, then it might be a good time to switch from Google Colab's free version to either a paid version where you get a specific machine assigned to you, or start using your own machine. But yes, you can install any packages. In fact, if I say pip install numpy, it actually executed the installation and said that requirement already satisfied. It's there in the package. So in this case, Philip, so they are only dev dependencies in the notebook. They are not global throughout your Colab account. So it's only specific to the notebook. So in the free version, at least, you can do something special to make this available throughout your Google Colab account. But I think for that you would need a paid version of the Google Colab. So. So yeah, like just for others, if you install like pip install numpy in your local environment. So if I would have done it in Conda in my local machine, then it would be there are different options of doing it, but it would normally, without any special options, you would have it available for everybody who's using your machine, right? And you don't have to keep on installing it. But in Google Colab, this is where the concept of virtual machines come in. So it's getting installed in this virtual machine that you have, and remember, each time you log out, you will not guaranteed to get the same machine. So they would erase all the installations that you would have. All right, so now that we have NumPy imported, remember, we can get helps from a function by using the help option. So let's actually start doing something cool. So let's actually start creating some NumPy arrays. So let's start making NumPy array. So I'm introducing another Pythonic object, and this is actually specific to NumPy. So it's an NumPy array. It's a specific data type, and it's a very, very nice way of defining arrays, which could be one-dimensional, two-dimensional, three-dimensionals, and n-dimensionals. What we use for scientific programming, right? So you can use NumPy to define arrays, and we will use a NumPy function called arange. So essentially, let's see what arange does. So let's use the help command. So we would say np.arange and see what it does. So arange is a function that returns evenly spaced values within a given interval, right? So this is how you define it. You define arange with a start, stop, and a step. Okay, so let's try to do that. So let's use arange to define something which we'll call data1. So we'll use np.arange, and we will define a number that we will define an array, sorry, that starts from 0 and goes till, let's say, 100, and we do it at a step of 2. Right? So this is how you define it. Again, this is we just learned about functions, so this is exactly how you would call a function, right? So np is numpy, dot a range is the specific function inside it, and then you would define based on the requirements for the function. So let's actually try and output that at the last line, right? So okay, so I'll get rid of the help statement because that's logging the view. So this is an array now that starts from 0, goes till 98, and the stop is not included, so you'll have to be a little bit careful there. If you want 100, then you would probably as your last value, then you should actually make the stop as 102. But in this case, this is just an example, so I don't really care if it is still 98. So starts from 0, goes at a step of 2, and gives you all the numbers that are between 0 and 100. Now I'll start introducing some specific things that you can do with NumPy arrays. So one of the thing that's used very often is to know what is the size of your array, and this is again um, because this can be multi-dimensional, you need to know what is the size of your array, and before you start playing around with it. So let's say if you are doing a matrix multiplication, you need to make sure that your rows and the columns have the same dimensions, right? So how do you find the size of the array? So size of a NumPy array. So to do this, you could use the NumPy array data1 in this case and just say dot, and then this tells you what are the different things that you can do. So you see there are a lot of different things that you can actually do with this NumPy arrays, and this is all part of the NumPy package. And in there is something called shape. So data1.shape, what it'll do is it'll just return you the size. So you have a one-dimensional array with the size of the dimension as 50. All right. Now let's do
And
something.
just to clarify,
Yep.
I have a question.
Mhm.
So with this array, do rows come first or columns come first? Is it seeing this as a 50 row single column or 50 column single row?
So in this case, there is no specific concept of row and column, right? Because this can be multi-dimensional. So you can have like 3-dimension, 4-dimension, 5-dimension as well. So we normally would say that the first dimension is 50, the second dimension is whatever your second dimension would be. And if you would like to think about them as rows and columns, I think yeah, so the first dimension would be rows and the second dimension would be columns. All right, so now let's go on and do something more with NumPy arrays. So let's try to generate random numbers, and we will just specify the size of the NumPy array. So we want to generate random numbers. Yeah. Uh, Output would be a 1D NumPy array, and then we would like to generate um, the the number of random numbers should be equal to the size of data1 array. Okay. Let's call this as data2. Right? So we will store that as a variable called data2, and then we will use something inside NumPy which is called random. So these are a set of functions which lets you generate a lot of random numbers. So you have a lot of different things in here. You can see that it's pretty powerful. You have Dirichlet distribution, exponential distribution, and stuff like that. But we will do something simple. We'll just use rand n, so essentially, or rand rather. That essentially gives you the so it essentially lets you generate um, the random numbers based on the length that you specify. So let's see data1 dot shape. And another thing to notice here is that you see there is the second part of this dimension is actually blank, right? So we need to make sure that we access the first dimension of this output. So we'll say it's index 0, right? So that actually gives you the number 50. So if I just execute this before I run the random numbers, so this will give you 50. But if instead of using this, if you just use data1 dot shape, then you would have actually this 2 dimension, although the second dimension is none in this case, but this is how NumPy works. So you need to make sure that you access the correct index, which would be the rows in this case. So this would give us data2, which are random numbers, and let's see what they are. So it generates 50 random numbers between 0 and 1, pretty small numbers in here. And yeah, so you essentially get random numbers generated. Now we'll do some more mathematical operations in here, right? So say more mathematical operations. And let's say we want to generate data 3, which is actually taking all these random numbers and multiplying them by 100. So we know that these numbers belong from 0 to 1. We want to scale it up by 100. So let's do that. So 100 times data 2. So this is like a mathematical operation. So what it does, it multiplies scalars with each and every element of this array. And let's output what we get in data 3. This cell. So now you can see that all these numbers are multiplied by 100. So now remember we talked about Boolean operations like before. So we could actually do all the Boolean operators inside NumPy as well with NumPy arrays. So let's try to do one, just an example. So we can do a comparison between what we had for data 1. So remember we had data 1 as numbers between 0 and 100 with a step of 2. And now we have data 3, which are random numbers multiplied by 100, right? So let's do a comparison between data 1 and data 3 and see, where data 1 is greater than or equal to data 3. So it's very simple to do it here. So we can say data 1 greater than equal to data 3. What it will give you is that it will output another array, and the array would have bunch of booleans. It'll be either true or false, and you would see that. So let's see. So we have false, false, true, and whatnot. So we have 50 numbers comparison. The length of this is also 50, and you can see that there are certain numbers that are greater than in data 1 as compared to data 3, and there are other cases where it's false. So now you can easily ask the question that how do I find out how many of these have true values, right? So in that you can use another function. So you can say data 1 greater than equal to data 3. That was what we had here, right? And then we can say dot sum. So essentially what it does is it just sums up all of this. So false is 0 and true is 1. So it would tell you, it will count all the truths and will give you the output and tell you how many true values we have. So in this case, we have 16 true values. So as such, we can say that as a comparison between these two 1D arrays, there are 16 numbers where the first array's numbers are greater than the second array. And this is a one-to-one comparison. So now we will do even more. So we can do some vector and matrix multiplications as well. So we can multiply data 1 multiplied by data 2, right? So it's a multiplication that is done in its true sense with the matrix multiplication concept. So we can say data 1 multiplied by a data 2, and let's see what the output comes out as. So this is again another. So in this case, this is actually a vector multiplication. I should mention. So, okay, so I think I'm going a little bit fast. So here is the data to, yeah. So thanks everybody for helping out each other. So this is data two, that's the random numbers that's generated with the size of data one as an input. Then we have data three, which is all the outputs from data two multiplied by 100. This is a just a scalar operator. Then we did a comparison between data one and data three to find out which numbers are greater than others, and then we just checked how many of these are uh, actually obeys this condition, right? And then we did quick vector multiplication where we did data one multiplied by data two, and we'll quickly go into matrix multiplications as well.
Hi, Vishal.
Hey,
Is this a good point for a break? I know it's a lot of material, but maybe 5 minute breaks so that people can stretch and refresh themselves before we can.
definitely. Yeah, no, sounds good, Michael. I think we can take a break now and rejoin at uh, after 5 minutes.
Yeah,
Okay,
maybe three.
all right, sounds good. I'll get some water.
Yeah, get some water. Let's just take a 5 minutes break and
Sure.
we'll continue.
Yep, thanks. Michael, let me know when we can start again. I'm back.
Okay, I think we can go ahead, Bishop.
Okay, all right. So everybody can still hear me and see my screen, right? I hope. So I did see there's a question from Philip, like whether I've changed any settings for my answers in scientific notation. So inside NumPy you can actually set the print options. So if I think by default it does show you the normal without the scientific notation, but I don't know why it's doing that. But you can actually set what kind of format you want, and that's like pretty you can control that. In fact, I'll try to do that in here. So what I'll do is I think it is numpy dot set underscore print options. Yeah, and I think you can put in suppress equal to true. I think this should do it for me. Let's see if it works or not. Yeah, so you see now I've got it back into the format, and this is like another. I mean, this is kind of an advanced topic, but you can actually specify the exact format that you want for each and every output that you have. There's a formatter, I think, inside here where you can specify the exact scientific notation that you want. But yeah, so that actually, I hope it brings it back to what you guys can see on your screen and how you can relate it better. All right, so now let's define more than a one-dimensional array. Let's define a 3D matrix and do some matrix operations. So let's define 3D matrix. Yeah. So now let's call it data 4. So we had till I think data 3, right? Yeah, so we had data 3, which was 100 times data 2. Okay, so we have now data 4. Okay, we'll define an array and we'll see previously we haven't defined explicitly the array. We had used functions, right? So we had used arange as the function that gave us a one-dimensional array. Then we used this random .rand function to give us another array. Now we will explicitly mention the the terms of a function. So to do that, what you need to do is you say np dot array. So that's how you tell the computer that you are defining a numpy array, and then you open parentheses in here, and then you open square brackets. Okay, so this is a little bit tricky, so make sure you do this. So you open parentheses, then you open the third brackets, and then in this case I'll define a matrix. In fact, let me actually write it down for you guys. Matrix equal to, so this is how we'll define 1 comma 2 comma 3, right? I don't know how to make it. Yeah, so 1 comma 2 comma 3, 4 comma 5 comma 6, and 7 comma 8 comma 9. Yeah, so this is the matrix. In fact, in a real world, we would put a long third bracket in here. So this is what we'll try to define in here. So we'll again open a third bracket to mention the first row, right? So let's say 1 comma 2 comma 3. Then after we have defined this, we'll place another comma, define the second row, 4 comma 5 comma 6. And then we will define the third row with another comma, 7 comma 8 comma 9. Yeah, so this is how you define uh, yes, perfect. Thank you. I like this when I miss something and somebody catches that. So yeah, so definitely you need to comment this out, and sorry about the formatting. I'll try to bring it back. I think this is better. All right, so now we have this data 4 defined. Let's see how it looks like as an output. Data 4. Yeah, so now this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember, we said that we can check the shape of a NumPy array by using the shape function. So data4 dot shape, and in this case, the shape should be 3, 3, right? So we have 2 dimensions. Each dimension have 3 elements in it. Now, let's again use the random function to actually get another data with a particular dimension. So I'm going to use the dimension of 4, 3 just to show you how matrix multiplication works, or you know how NumPy does the multiplication in this case. So let's say data 5 is equal to numpy.random.rand, right? So that was again, remember, this was what we used right at the start to get random numbers between 0 and 1 um, uh, with the dimension of the data1 array. So but now I will explicitly mention the dimension. I'll say that it's 4, 3, right? So, and then we will say what is data 5. So again, so now it will have, you know, 4 rows and 3 columns, right? So this is how the matrix looks like. And now, if you remember from your matrix multiplication days, so you should have the columns. If you are doing matrix multiplication, the column and the row should have the same dimension, right? So that is how matrix multiplication works, which is not the case in here, right? So data 5 dot shape is actually 4, 3. So ideally, you should not be able to do a matrix multiplication in this case. So let's try what happens if we try and do this multiplication using matrices, right? So let's say, so remember again, data 4 is what we explicitly defined, right, with the shape of 3 cross 3, and data 5 is something that we generated randomly using the shape of our random number to be a matrix of size 4, 3, right? So we will try to multiply them together. Okay. And this is where we get an error. So you need to understand these errors as well. So if you see here, we have the search Stack Overflow already in here. So it kind of gets you to the place where you can find what is this error um, specifying. So I have a question. Let me take that. Let's see. Data 5 is numpy.array. So yeah, you're missing a third braces in here. Let me actually try and do this again. So yeah, this is kind of the tricky part. So you have defined it, but you need another square bracket before this. So this is what you were missing. So if you do not have that square bracket, then you would not have what you want. So I hope that helps. All right. So what I was gonna emphasize on is that so this actually tells you that we are doing matrix multiplication in here. So if we had to do the matrix multiplication in this case, if we wanted, if we had accidentally not wanted this, but we would have rather wanted the rows to be 3 and the columns to be 4, then the matrix multiplication would work, right? So what you would do here is we'll try to define the matrix multiplication, right? So we'll say numpy dot transpose. Yeah, so remember the transpose operator that we had in matrix. So that actually transposes the rows and the columns, right? So if you do this, what you get is number of rows as 3 and number of columns as 4, right? So it just did the transpose of this whole thing. And now if this is because right now we'll now satisfy the conditions for matrix multiplication, right, or matrix algebra. This is basic algebra. I'm trying to show you how we do it using NumPy operation. So what we'll do is now we'll try to get the matrix multiplication. So we use what is called matmult, matmul, and then we will say data 4, comma, numpy dot transpose of data 5. So this will actually do the matrix multiplication in this case. So you get the product, which is again, if you remember from your matrix multiplication, there is if you multiply 3 comma 3 with 3 comma 4, you should get a 3 comma 4. So that's a quick check. So 3 rows and 4 columns in there. Okay, so Danny, um, do you understand this part where, you know, the difference in between your code and my code is that I have another square braces that is encompassing the code that you have. So you didn't have this guy and this guy. So you need to put that in. That's how it is defined. Yep, no problem. No, I can completely relate and understand that, you know, this can be confusing, but this is how, once you start using NumPy, you will understand this is a little bit tricky in there. Okay, so I have another question. Can you explain what this means again? numpy.random.rand. So I mean, I have computers to actually help me answer a lot of questions, so I will do something which I always like to do. So I'll do help and I'll put this thing in here. All right, so what does it do? It's a method of numpy.random.empty_random.random state instance. So it gives random values in a given shape. So essentially what it is doing is that it's a convenient function for users porting code from MATLAB, blah, blah. That doesn't help much, but it's creating an array of the given shape and populate it with random samples from a uniform distribution over 0 to 1. So this is where, you know, it's a statistical way. So you have if you guys are aware of probability density functions, then you would know that a uniform distribution has a flat line over the range, right? So the range here is 0 to 1, and if you remember this kind of notation from your you know school days or college days, wherever you learned this. So this means that 0 is included and 1, and this means that 1 is excluded. So what it is doing is essentially it's trying to randomly draw from that distribution n number of samples, and n being the number that you mention as the shape, right? So in our first case, we had the shape as 50 one-dimensional array, so it's giving 50 numbers, and the other case we had a shape of 4 comma 3, so that was giving us random numbers between 0 and 1 with this particular shape. So essentially it's drawing from this uniform distribution which is defined in between 0 and 1. Does that help a little bit? Yes, no, maybe, kind of. Yep. Well, I'd encourage you guys to like look at uniform distributions and what it really means to randomly generate from uniform distributions, right? This is, you know, it's not as simple as I make it sound, or as this is doing. So there's a lot of research, actually. Fun fact, and you guys can appreciate this more than anyone. So essentially what we are doing is we are trying to get random numbers in between this particular you know, uniform distribution that we have, and it's not an easy task, right? So it's not purely random. There is something behind this, and there's a lot of research being done, and there are a lot of different ways of generating random numbers. You guys if you're interested, you guys should Google this. How are random numbers really generated? Or one of my favorite topics to search in this area is, are random numbers really random? Maybe you guys can search that as well, and you would find out how interesting and how it has evolved. Now it has come up to a stage where they're using some, you know, some ways of measuring the state of a particular element as it goes from one state to another to actually define the random number. But it's a really interesting science behind it. But in this case, yeah, that's actually coded for us. We don't have to worry about what the algorithm is, and yeah, we just use the function to generate random numbers. And another question that you guys might have is that, you know, if you're using random numbers, maybe you want to generate random numbers, but for replication of your results, to for, you know, reproducibility, it's a term that's used a lot in scientific research and scientific computing, that you want to reproduce a result. So in that case, you would like to make this random numbers spit out the same set of random numbers every time. So it cannot be completely random, right? So in that case, you can actually you know, set a seed for these random numbers. Setting a seed for the random numbers actually helps you reproduce results. All right, what else do we have? Can you show okay, before that, does transpose just change the number of columns to the number of rows and vice versa? Yes, it does, if it's a real number, right? If it is a complex number, then it also does a complex conjugate of it. So that's a little bit more details, but in this context, it's just flipping the rows and the columns. That is true. Could you show what is data 5? Sure, definitely. Let me see what is data 5. So data 5 is essentially this particular thing. So thanks, Pragya, for mentioning that. What is random? Is that a pun intended? Yeah, I don't know. What do you mean? What is random?
Sir, actually, I have left the meeting because of some poor connection. Can I know in your one line? Already, I have some experience in this.
Yep. So random is what this particular thing reads out. So I would encourage you to use the help function and type this np.random.rand. And if you have anything specific in here, I am ready to answer. But what I explained was that you're trying to draw samples from a uniform distribution that's defined in between 0 and 1. That's how this particular function works. Okay, right. What is random was a great question. Sometimes I also wonder, what is random? Do we have randomness in everything that we do? But anyways, that's philosophical, I think. All right, so let's go and do something more. So now we will do uh, solving some system of equations, right? So that's where, you know, all the algebra and the matrix linear algebra concepts come in, and we'll try to see how easy it is actually. So once, if you guys are taking linear algebra class, now you can solve your homeworks like in a split of a second if you use NumPy. But yeah, but it's also good to understand how it works. But let's try to solve a system of equations. And in this case, I'll have two equations with two unknowns. So it's a case where we have one specific solution, right? It's not an overdetermined or underdetermined problem. So I'll have my first equation as 6x plus y is equal to 19. And my second equation is x over 2 minus y equal to minus 6. Let's say we have these two equations. Now how do we solve this, right? So in order to do that, first let's define the coefficients that we have here, right? So we have the coefficients at 6 and 1. So we have two variables, right? So we'll have 2 cross 2 as our matrix, and then we'll have the constants, which is uh, 2 rows and 1 column, right? So that's how we define in our matrix operations. We'll try to replicate what we do in linear algebra. So let's say coefficient is our NumPy array, which is 2 by 2. Again, remember how we define it. We open a single, like the first braces, and then we have a third braces, and inside that we again have our rows and columns. So we'll define it row wise. So our first row would be 6 and 1, right? So that's the first equation, 6x plus y, 6 comma 1. And our second row, which is how we define by using a comma separator. So we'll again open our square brackets, and our second row is 0.5, which is 1 over 2, and minus 1. That's the second coefficient, right? So these are the two coefficients in here. All right, so we now have defined our coefficient, and now let's define the constant part, which is on the right hand side, right? So constants, this is a one-dimensional array. So we'll again define mpy.array, and then again we open our first braces and we open our second braces, and now we don't need to have another square brackets in here. This is a one-dimensional array, so we can directly define it as 19 comma minus 6, right? So these are our two constants on the right side. All right, now this is a scientific scientific computing tool, and it has functions that would solve these equations for you. So let's say we say our result is actually equal to, so we'll try to solve this equation, right? And for that we'll use a function called linear algebra dot solve. Okay, so we'll go into NumPy, we'll say dot linear algebra dot solve, and then we'll say this particular function takes as its first argument the coefficients and the second argument as the constants, right? And then the result of it would be the solution of x and y. Right, let's execute this. Unable to connect to the runtime. Oops. Now I understand where you guys were saying that it's disconnecting you guys from the things. I don't know. Let's try to open a new notebook. Yeah, now it's connecting. Yeah. NumPy is not defined. Yeah, we know that because it's a new text thing. So I'll just say import NumPy as an. This should actually work. Yeah, it worked. And let's see what our results are. 2 and 7, right? So that's actually solving, we know that's the solution. 6 multiplied by 2 plus 7 is 19. 6 divided by 2 minus 7 is minus 6. So it has done what it's supposed to do. Cool. And we'll send out some exercises at the end of today so that you guys have some chance to work on this and explore this on your own. So I'll stop with NumPy at this point and open it up for any questions if you guys have. If not, we'll go into pandas. So is NumPy mostly for array and matrix math? It is for scientific computing, right? So, and yeah, you're right, it's for, arrays and mathematical operations. So anything that you need to do with, scientific computing, that's where the package has its most usefulness.
So don't we have some other methods to find to solve a system of equations without using this NumPy?
Great question. So do you have anything in mind?
Actually, I am unfamiliar with all these.
So I think that would be a good place where you should go and revise some of the linear algebra, right? So you can do all the matrix operations to get the solution of systems of linear equations. So yeah, I think
Thank
yes. Yes, and definitely there are different ways of you should try and use Google to find out if you're not satisfied with what NumPy is doing, right? But the whole focus of today's lecture is to get you guys introduced to this package called NumPy. I think I hope you guys are appreciating the fact that this is a very, very powerful package for scientific computing. So if you're trying to do scientific computing and if you're doing it on a regular basis, I would be very surprised if you're not using NumPy and using some other package for doing it. Okay, there's another question, and can you scroll up so that I can see data 5 lines of code? Yes, Pablo, I think that's data 5. And then I had this data 5.shape and the things like, did you miss out on a particular aspect? You can come off mute and ask me. I can help there. Or write in the chat. Maybe somebody else can reply to it as well. So other question, what is the difference between data1.size and data1.shape? And yeah, so I think you got your answer there. So size is the number of values, shape is the shape, like a 3 by 3 matrix. I like your answer, Philip. I think we should talk about what is random as an answer as well. Like, but yeah, that's exactly true. Yeah. All right, good questions, guys. Keep them coming, and I'd encourage you guys to, also once you have the question, you should also try it out, right? This is where things are pretty good and powerful in the way we are learning stuffs, right? So I could just check, result dot shape, and that would give me this particular thing, and result dot size. So in this case, maybe you would not see much of a difference, but you can see that it's giving you what Philip and David were saying, right? So it just gives you the length versus the rows and the columns. All right. Any other questions? Or are you guys excited to go into the world of pandas? It's not the real pandas, it's a package, by the way. I'm sorry if any of you guys have pandas as your favorite animals. I don't know, it's interesting. Maybe I'd like you guys to find out why the name pandas actually. Maybe there's an interesting story behind that. I don't know about it. Does solve expect those particular arguments? So again, to answer that question, what I would do would I'd go into the help for this particular function, right? So I'd use help and I would put this function. And in here, remember when we wrote our function, we actually followed this particular style, right? So it tells you it expects two different parameters in here. A is like a coefficient matrix and B is the ordinate or the dependent variable values, right? So that is what it requires. Okay, so somebody has actually done the Google search, and let's see. So I guess, yeah, it's a good time to, go into pandas, the world of pandas. And the name is derived from the term panel data, an econometrics term for data sets that include observations over multiple time periods for the same individuals. Yeah, now it makes sense. Pandas. So yeah, if there are any economists in there, you guys, I guess this is something for you guys, and also for finance people, right? So it's a great tool for doing a lot of financial time series analysis and stuff like that. But before I go there, Michael, do you have any comments on the NumPy, or do you think we should be good to go into the pandas world?
No, I think we're good to go. We're going to say, I know it's a lot of materials that we've covered, but we'll send the videos and we'll send some exercise for you to practice. And Google is your friend. Do some more research, get more into it, and you would continue to enjoy the power of this NumPy.
Yeah, I agree. Good deal. So let's go into pandas. So yeah, so let me actually try to bring the pandas website for you guys so that you know. So we have pandas.pydata.org. It's a very Powerful package. Again, it's endorsed by a lot of people, a lot of different organizations, and it's a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool built on top of the Python programming language. Yeah, I think that is a great one-line explanation. And people have, like, specific courses on pandas, and there are lots of powerful analytics that you can do with it, but here we are trying to just uh, brush the surface of pandas and see how we basically get started with it, and then I hope that would actually open up the world for you to use it in your day-to-day world. So like any other package, we would first import pandas, right? Again, this is something that comes pre-installed with Google Colab, so you don't need to install it. And normally we import pandas as PD. That's how we try and import pandas. And then again, like np dot, we would use now pd dot. Right. So now in pandas, and this is where it's specific to the packages. So I've already shown you something in NumPy. So NumPy arrays. So if you're working with NumPy functions and all the stuffs, NumPy array is something that you would use normally. And in pandas, what they use is pandas data frame. So this is again derived from how things were defined in R, and a lot of these packages come from R, right? So they try to maintain the structure. It's called data frame. So let me actually put a note there. So most common data structure in pandas is data frame. Now you guys might have a question that which one should I use? Are these interchangeable? Yes, they are perfectly interchangeable. Some of the pandas pandas functions require you to have things in data frame, but you can always transform a NumPy array into a data frame, and vice versa. So and I think, if I'm not mistaken, data frame is based out of dictionary. So it actually has this keyword and the value type of a structure in there. So but remember to take a note of this, that if you guys are using pandas for most of your work, and in pandas you can do a lot of different things, and also if you're using SciPy and packages like that, they normally like to have the data in a data frame format, and we'll see how we define a data frame. All right, so let me actually start off by defining an array. So this is where we like to define, let's say again, taking the example of the car, we'll define the car model and its year of manufacturing. Okay, so you open it with a third the square brackets, and then inside it you define each and every value for it. Okay, so this is how, and you'll get more clarity on this. So if you guys are having some doubts on how this is happening, I think it'll be clear in the next two lines. So we define an array like this. So we say, let's say the first car model is Accord and the year of manufacture is 2020. Then for the next one, we have this again, another square brackets. We have the second model, which is Civic, and then we say comma, the value is 2010, say, and then we have the third one, which is a Corolla, and then we say that this is a 2015 version. Okay, we define this array, right? So this is basically going back to your the first day of the week. So we have this array where we have the name of the model and its year, right? Now pandas let you take this array and convert it into a data frame. So how do we do that? So let me put a heading here, create a data frame from the array. So let's name the data frame as df, and we will use a pandas function here. So pd dot data frame. So that's how you define an array, define a data frame, sorry. and inside there you put in as an input the array that you want to convert into a data frame. And in fact it gives you more control, and you can see here like it takes in a lot of different arguments. You can make it a really fancy one, but there is one argument called columns which actually helps you to give headings of the columns, right? So in our case, we know the two headings. So this is the model and this is the year of manufacture. So let's use the columns keyword and make the first column as car model, right? And the second column as year of manufacture, right? So this is our data frame. Okay, so what we did was we took this array that we defined before as an input, and we defined the column names, SCAR model and year of manufacture. You could have skipped this column names, but it just helps to, make it a nice looking data frame with properly indexed columns. So let's see if what this data frame looks like. So this is how the data frame looks like. So it is almost like a spreadsheet, right? So you have the different rows in here, which tells you about the car model and the year of manufacture. I saw there were some questions, I guess. Yeah, so Natalie, you're exactly spot on. So Pandas optimizes operations using data frames, so it is better to use these. Yep, that's exactly true. In fact, if you're trying to import a CSV or an Excel spreadsheet into Python and trying to do operations using that, it's actually orders of magnitude faster, especially if you have a big CSV file or big Excel spreadsheet with a lot of values. It's actually orders of magnitude faster if you try to import it using the Pandas and the SciPy library. All right. Creating the UI tables with arrays. Okay. I don't think I understand that question. So I'm not sure about the question about the UI tables, but I can paste the code. I guess you're asking about this one, right? So I'm gonna paste this here. Hopefully that helps. And I have it in the screen in case, oh, maybe I can also paste this guy. Yep. So another question: how do you start the index on 1 instead of 0? So this is how Python works, right? So the indexing always for anything starts from 0, and Pandas data frame is not an exception. I see Philip has answered as well. You can custom set the rows with using index. So that is true, but essentially that would mean that the first index is empty. It's not that by design of how these things work, you would always start it at 0, but the 0 1 would be empty, and you would essentially start from 1 2 and so on. But again, because you guys are starting off, some of you at least, I would say, like, if you're using Python day in day out, you would realize that that it's quite naturally it'll come to you that the indexing starts with 0 and not with 1. All right. So now let's look at how do we access the data that we actually put in the data frame, right? So accessing the data in data frame. So the way to do this is using the LOC location function inside data frame. So we can do df.loc, and that'll give you the access to the indices. So you can just say, let's say we want to extract the first row in here. So we are just indexing it with 0, and this should give you access to the car model, which is Accord, and year of manufacture 2020. So already you can see that instead of previously when we were trying to access data, so if we had not used the data frame, um, if we had just used, let's say, a NumPy array that we learned just before this, it would actually give you just accord and 2020. But here, the way data frames work is that you can access things using the column names, row names, and stuff like that. So it becomes really powerful, and you can see that it not only gave you accord and 2020, but it also gave you the corresponding column names as well. So the car model is accord, and the year of manufacture is 2020. So essentially, depending on the type of problem that you're solving, if you're trying to solve, let's say, an Excel spreadsheet in order to maintain an inventory of cars that you have in your garage, let's say, and you wanted to output something informative, then this is something that might be more useful for you. All right, so now let's actually try to add another row of data into this. So how do we do that? Let's try to add a row to the data frame. Okay, yeah, that's so you had 3 cars. Now you've added the 4th one to your garage, and you want to add that to the data frame that you're maintaining as in using Python's data frame. So you'd say that you had 0, 1, and 2 indices. Now you add the 3rd index in there, and then you got, let's say, a Mazda CX-5, and you got it using a pre-certified owned car with a model that had a year of manufacturing as 2012. So this is how you would add the data. So again, using the location LOC function, right? So dot LOC, and then you put in the index as 3. That's the 3rd or like the 4th row in here, and then you defined it using the 2 information that you need. And now let's look at data frame. Yeah, so let's see what it did. So it has added this new entry into the data frame. So now let's say you have just started to maintain this spreadsheet, and now all of a sudden somebody comes in and tells you that, oh, we need some more information in this data frame. It just looks super cool, but we are missing the mileage information for all these cars. Let's add the mileage information. So you're trying to add a whole column with mileages, and you have 4 cars in your inventory, and the mileage for all of them. So how do you add a column to your data frame? So let's say adding a new column. Right, so we'll say data frame. We will open your square brackets and define the name of the particular column, right? So it is by default telling you car model and year of manufacture are there already in this data frame, but we want a 3rd column, which we will call as mileage, right? And we will say, okay, this is just a list with the mileages. So let's say the first car had 2020 car probably has a lot less mileage, 1,000. 2010 would be 20,000. Let's say it's being used heavily. The 2015 one was sitting in your garage. You don't like your Corolla. It has 1,000 mileage on there, and let's say your Mazda one that you got recently has got some mileage in it, 30,000. Okay, so that's my 4 numbers that defines the mileages for all these um, car models that you have. And let's now look at the data frame. So hooray! So we have the new column with the mileage, and you can see that you have the numbers that you input in for the mileage, and you can start inputting more numbers in there. All right, so now I will try, and I know I'm little going short of time, but maybe it's actually I'll stop here for now. I'll have certain things to cover tomorrow as well, so we might keep the discussions a little bit shorter and actually cover a little bit more about pandas and give some time for you guys to grasp all these concepts. But yeah, I'll stop here and yeah, maybe take questions or comments from you guys. Yes. So there is a question about, do searching and sorting algorithms work with data frames like they do with arrays? Yes, they work. And the good part of data frame is that you can extract a particular column or where whatever you want, like so basically this LOC function lets you access each and every data in this particular data frame, right? And then you can convert them into an array. So let's say you're using a NumPy sorting, so you can actually say NumPy dot array and put this thing as an input in there, so that'll convert it into an NumPy array, and you can use that for all your algorithms for sorting and searching. So yeah, it does. If we don't know the row number and want to add new row to the data frame, how can we do that? So you can find out using the data frame. So you can find out what is the last index that you have, right? So based on that, you can say, okay, last plus one is what you are trying to get. And maybe that I'll leave it to you, Madhuri, to actually find out how you find the size of a data frame. That might be a good question to Google. Any other questions? How do you delete and I guess how do you delete an extra column? Yep. So you can actually use the data frame delete option. So inside data frame, if you put data frame dot, yeah, there are different ways of um, doing different operations with the columns. So you can either make a new data frame from an older data frame and just take in the columns that you want, or you can just remove a particular data frame. So there are different things like drop level, what exactly you're trying to drop. There are other drops, like this is very very common if you're using data frame, and especially if you're doing linear regression or any statistical method here. So if you have NA values, which is not applicable values, then you might want to drop those rows and things like that. So yeah, you name it, you can do most of the things in data frame. So yep. Why do we need all these? Yep, good question. So this is so data frame is a thing which is specific to pandas and also for SciPy. So some of these packages actually require you to have a data frame, and this is on top of actually having a very structured way of maintaining your data. So you see how nicely it formats it. It's also like somebody mentioned before, it gives you a computational advantage as well if you use data frame and functions that accept data frame. So those are a few out of the many reasons why you would need all these. How to delete duplicate data from data frame? Yeah, another good question. So another thing to search in Google. So maybe it's a one-liner or a two-liner, but definitely you can find duplicate values using you know different ways in data frame very very easily. So yeah, without giving you the specific code, I can tell you that it's possible. Can we update a value based on a parameter? Example, Corolla's year of manufacture is 2013 and not 2015. Yes, you can do that. You can update, you can get the location of your exactly what you're trying to get at. So you can say that you can use a boolean saying that df dot car model, if it's equal to Corolla, then your year of manufacture should be, instead of 2015, it should be 2013. So you can update all of those things. So the way data frames work is, it doesn't there is a restrictions on changing data inside a data frame. So what and the philosophy behind that is data frames expect you to do a good QC before you get into like before you get data into a data frame. So I think you kind of mentioned so df.update, right? So that's how you update it. So it's not allowing you to change anything directly without using that df.update function. So that's where it comes from. Yeah, Natalie, you're spot on. You can also do easy visualizations inside data frames. So in fact, on that note, actually, I'll show you, and we'll try to see this. So this is we'll go through this tomorrow. We'll import some data inside our collab notebook, and you can easily, so you see this is like one line of code using a package called Seaborn. We will talk about this in the next week as we go through the visualization. Just one line of code, and you get this powerful plot. And let me actually zoom out a little bit. This is something which a data analyst would do every time he or she gets the data before going into the data. So this gives you a histogram of the data. This is what is called a pair plot. So it gives you the correlation between each two variables, right? And that's only possible if you have the data as a data frame. It might take some extra steps of coding if you do not have it as a data frame. Also another pair plot here, more fancier. You're trying to look at three different variables and trying to color them according to a particular species and stuff like that. So we'll look at the iris data set tomorrow, and it's actually something that's very famous in statistics, and yeah, we'll try to see how we can use our um, pandas notebook to actually plot all of these things. All right. Is this similar to a relational database in Postgres using SQL? That's a question I'll not dare answer, especially because we are recording this session. I'm not an SQL expert, so sorry, Philip. My bad. Okay. Is this similar? So tic-tac-toe. So what about tic-tac-toe? Do you want to play tic-tac-toe? I can tell you that if I start first, you cannot beat me. That's for sure. Okay, what else? Okay, yeah, I think that actually summarizes most of the things. So Michael, over to you. I think we are just over time for today.
Oh man, very round of applause for Vishal. Vishal, thanks a lot for walking us through this. A lot of good material. NumPy, I learned a lot today as well from you. And also we scratched the surface of pandas, and I think we'll finish it up tomorrow. Thanks a lot. And thanks to all the participants for today. Very rich discussion. I like all the questions that are coming on the chat and all the responses from various folks as well. So thanks for the active participation. This is very encouraging, and it's only going to get better. Tomorrow we'll show some more stuff. We'll introduce some of you to some GUI. We talk about tic-tac-toe. We'll show you some other games that you can build using Python. So the list is endless. The things that you can do once you have this skill is very endless, and this is just the beginning. So thanks a lot. Sorry we went past time, 4 minutes past time, but I really appreciate all the participation. So today I'm going to send the recorded video so that you can have time to review it. We'll send the Collab notebook as well so that you can go through everything that was covered today. And there's going to be a small exercise that you can play with as well to just reinforce knowledge. And tomorrow we'll discuss more, and we'll provide a project that you do within the week. And we'll also be grading the last week project, and you'll be seeing your grades updated today or tomorrow. Thanks a lot for your active participation once again, and we'll see you guys tomorrow.
Thank you all. Thanks for attending. Thank you, Vishal, Michael. Appreciate.
Thank you.
Yeah, thanks everybody. See you tomorrow.